Hi, Assalamualaikum, salam sejahtera. Okay, so let's discuss tutorial 1. Okay, so please focus on the explanation. Okay, how do we answer the question and what is the hidden info do we have in that question? Okay, so good luck. Okay guys, so let's start by discussing the objective question. Okay, let's start by question number 1. Alright, so this is the question. Okay, which of the following statement is correct about an electric field strength at a point? So the answer just between A, B, C or D. So according to this question, the keyword given here is which statement is correct for the electric field strength? So we need to know, what is the symbol of electric field strength? The symbol is E. So what is the equation of E do we have in that chapter? Okay, from the first equation, which is from the definition, which is F equals to QE, so that we know that E equals to F over Q. Or the second equation, how do we calculate the electric field strength for any isolated charge? The equation is E equals to KQ over R squared. Okay, from these two equations, which statement is correct? Okay, so let's start by the first one. A, it indicates the electric force per unit mass. Force per unit mass is not, but here what do we have? Just force per unit charge, isn't it? Alright, it indicates the total charge on a particle at that point. It's wrong too. It indicates the electric force per unit test charge at that point. Force per unit test charge. Okay, seems like correct, isn't it? F over Q. Alright. And D, it indicates the electric charge per unit mass. Okay, it's wrong again. So the answer is C. Okay, so this is the answer lah. C. Okay, question number 2. Which of the following diagrams shows the electric field pattern between two equal but opposite charges? Okay, so remember, we have two different type of charges, which is a positive charge, also a negative charge. And therefore, any positive charge, the direction of electric field must be directed outwards. Outwards. While for any negative charge, the direction of E should be inwards. Okay, alright, so let's check the pattern of each answers given now. A, okay, positive is directed outwards, negative just directed inward. Positive and negative, they attract each other. Okay, seems like correct. For B, positive should be outward, but now seems like everything just goes inward, isn't it? And then for the negative one, it just directed outwards. Okay, it's wrong. It doesn't obey the principle, isn't it? Okay, B wrong already. And then for C, positive is the electric field just directed outwards. Okay, correct. And then for the negative one, it just directed inward. But remember, according to Mr. Coulomb, positive and negative charge or different charges, they will attract each other. But now seems like they are repelling each other. So C also wrong. Okay, and then for D, again, positive and negative, see, repel each other, already wrong. And then positive just goes inward, and then negative just goes outward. Okay, this one also wrong. So the best answer is A. Alright, for number 2, the answer is A. Before that, remember, the keyword given now is two equal but opposite charges. Two equal, but what does it mean? They are equal in magnitude but opposite in sign. Alright, so what do we have now? One of the particle is positive, the other one is negative, but equal in magnitude means that the number of lines should be the same. For example, here for the first charge, the number of lines do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 lines representing the electric field. So for the second particle, it must be the same. There must be 8 lines. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So remember, because the line now representing the strength of the electric field. or the electric field strength lah. Alright, so remember that. So the charge now are equal, then the number of lines should be equal. Okay. Next, number 3. An electron in the electric field has electric force acting on it in what direction? Okay, so there is an area with the electric field strength E. So these 6 lines now representing the electric field, which is directed to the right. And then there, we just put a negative charge into that area. Okay, so the force exerted on that particle or charge now just directed to the north, to the south, to the east, or to the west. How is it? Okay, so remember, for the electric field, it always starts from positive pole towards the negative pole. So this area now representing the positive pole. The electric field always starts from the positive pole towards the negative pole. So this is the negative area lah. Okay, so E directed start from the positive area towards the negative area. So remember, now we are talking about a negative charge. So according to Mr. Coulomb, negative charge always attracted to the positive area, isn't it? So the force exerted now just towards the positive area. So the force must be directed to the left here. So this is the force, the electrostatic force. So based on this, a negative particle attracted towards the positive area. So Fe just directed to the left, or based on this direction, it just towards west. So the answer should be D. Okay, so let's continue by question number 1, which is under subjective question. Okay, what do we have now for this question? Alright, the question is 3 point charges given now, which is placed at the following points on the x-axis. Okay, Q1 at x equal to 0, and this is the magnitude. Q2 at 40 centimeter position, and this is the magnitude. And Q3 just located at 120 centimeter position. Okay, and then this is the magnitude. So Q1 is a positive charge, Q2 and Q3 is a negative charge. Okay, find the amount of net electric force exerted on Q3. Okay, on Q3 by Q1 and Q2. Alright, so based on this, I think we need to sketch a simple diagram. So what do we have now? This is the particles given now, which is Q1, Q2 and Q3. So Q1 located at origin, which is x equal to 0, and then at x equal to 40 centimeter there. Okay, and then we just have the second particle, which is Q2. Okay, and then at 120 centimeter, okay, we have the third particle now, which is negative. Okay, alright, so now they ask you to find the amount of electric force exerted on Q3 and by Q1 and Q2. Okay, so we just do it step by step lah. First, we need to know the force exerted on Q3 caused by Q1. Ignore Q2 first. Okay, so Q1 is a positive charge, Q3 is a negative charge. So positive and negative, they will attract each other. Okay, so the force exerted on Q3 now just towards left lah, or towards Q1, because they are attract each other. Okay, so that one is F31. So F on 3 by 1. Okay, at the same time, the force also exerted on 3 by 2. How is it? Check the sign of each charges. Q2 is a negative charge, Q3 also a negative charge. So negative and negative, they will repel each other, isn't it? So by repelling each other, the force exerted on Q3, it must be directed to the right. Okay, so that one is F32. F32 means that the force exerted on 3 by 2. So this is the force exerted on Q3, which is F31 and F32. Now they are in opposite direction, so one of the force should be negative. So basically, to the right we take it as positive, to the left we take it as negative. Alright, so we just calculate F31 first, also F32. So F31 equals to KQ3Q1 over R31 squared. Substitute the value of K, the value of Q3, Q1 and R31. R31 is the separation between Q3 and Q1, okay, which is 120 centimeter. But remember, in substitution here, it must be in meter. Okay, so 120 equals to 1.2 meters lah. 120 centimeter equals to 1.2 meters. Substitute all the values and then you will get the answer, where the force now just directed to the left. One more thing, remember, force is under vector. So for any vector in substitution, we just ignore the sign of the charge. Okay, we just take the magnitude only. Why? Because positive and negative now representing direction. Okay, so F31 now just directed to the left. So in calculation later, to the left should be negative lah. Okay, we just do the same thing in calculating F32. F32 equals to KQ3 Q2 over R32 squared. So K is a constant, just a constant, which is 9 exponent 9. Q3 is the third charge. Q2 is the second charge given already. Okay, substitute into this equation. And R32 is the separation between Q3 and Q2. Q3 and Q2 equals to 120 minus 40, giving you 80 centimeter. So 80 centimeter still equals to 0.8 meters. Okay, so remember, in any calculation, R or separation now should be in meters. Okay, so we just substitute all the values. Again, force is under vector, so we just ignore the sign of each charges here, which is negative and negative, isn't it? We just take its magnitude only, substitute, and then you will get the answers. And then remember, force now is under vector, so it just directed to the right. Okay, so remember, no positive and negative sign in the substitution. We just take the magnitude only. Alright, and then what happened? So how do we calculate the resultant? So the total force exerted on Q3 equals to F31 plus F32. So this is the vector, vector of F31 plus vector of F32. So F31 is directed to the left, so it must be negative. And F32 just directed to the right, it must be positive. Okay, so substitute the value of F31 getting before 0.0625 Newton negative, and because it's just directed to the left. And the F32 getting out is 0.211 Newton. Substitute here, it must be positive because it's just directed to the right, isn't it? And then total up the values, you will get the answer to be positive. What does it mean? It means that the resultant force just directed to the right. Okay, so this is the way how do we answer the question. So for any vector quantity, remember, in substitution we just ignore the positive and negative sign. We just take the magnitude only. But remember, we need to check its direction. Okay, when it just directed to the left or downward, it must be negative. When the vector just directed to the right or upwards, we take it as positive in calculating the resultant. Okay. Alright, so maybe some of you still confused. How do we get these two forces which is directed to the left or to the right? Let me show you again. Okay, by giving you two different charges. And the first charge, the second charge, and the third charge. Where the first charge is positive, the second charge is negative, and the third charge also negative. Alright, they ask you to find the force exerted on Q3. So the force exerted on Q3 just by these two charges, which is Q1 and Q2. Okay, so we just ignore Q2 first. Between Q1 and Q3, 1 and 3, we are talking about different charges, which is positive and negative. So they will attract each other. So what do we have? These two forces, which is F13 and F31. They are attract each other. At the same time, the force also exerted on 3 by 2. So negative and negative, they will repel each other, isn't it? So the force exerted now is just like this lah, which is F32 also F23. Actually, other than that, 1 and 2 also react to each other, isn't it? So positive and negative, again, they will attract each other. So what do we have now? We have another forces here, which is F on 1 by 2, also F on 2 by 1. But remember, the question just asks you to calculate the resultant force exerted on Q3. So we just focus on this part only. Okay, we just ignore these two charges. We just refer to this only. So seems like F31 just directed to the left and F32 just directed to the right. So this is the way how do we identify the forces exerted on that particle. Okay, remember that. Okay, now let's continue by the second question, which is number 1B. Okay, one charge given now, which is Q1, which is positive 5 microcoulomb, is placed at the origin, again at x equal to 0, and a second charge, which is Q2 with 7 microcoulomb magnitude now, is located farther along the x-axis. The resultant electric force experienced by the third charge, Q3, is 0 at position x equals to 45.8. So where is the 7 microcoulomb charge should be located on the axis? Okay, so they ask you to find the position of Q2. Okay, they ask you to find the position of Q2. Okay, where the force exerted on Q3 equals to 0. And the force exerted on Q3 equal to 0. Okay, so what do we have for this? I think we need to sketch a simple diagram lah. Okay, so Q1 located at x equal to 0 at the origin. This is Q1. And then a second charge, Q2, is located farther along the x-axis. So this is Q2. Okay, we doesn't know the distance or separation between them. We just take it as x only. Alright, and then the third charge just located at 45.8 centimeter. At the same time, the force exerted on Q2 equals to 0. The force exerted on Q3 equals to 0. So the third charge now located at 45.8 centimeter. Okay, we need to know where is the position of Q3 actually. So I think you need to understand the concept first. Okay, so now by giving you Q1 and Q2. Okay, Q1 and Q2 separated by x. Okay, we doesn't know the separation yet. At the same time, we just put the third particle here where the force exerted on Q3 equals to 0. So according to this situation, there are 3 different positions, which is A, B, and C. We may put the third particle at A, or at B, or at C. But the condition is the resultant force exerted on the third charge should be equals to 0. So which position giving you F equals to 0, which is on Q3? We need to know this. So how to find the best position for Q3 to obey this principle? Okay, simple. For example, by locating Q3 at A. Okay, so A is at the left side of Q1. B is the area in between Q1 and Q2. C is the area at the right side of Q2. Okay, so we just do it one by one. Okay, we need to identify the best position for Q3 where the force exerted on it just equals to 0. Okay, so now remember Q3 given is it positive or negative? We need to check this one first. Q1 is a positive charge. Q2 also a positive charge. And then the resultant electric force experienced by the third charge Q3 is 0. Alright, now the charge is not given, isn't it? So we just take it as a test charge, which is positive test charge lah. Okay, alright. So I think still okay by using a negative test charge because the answer is getting now still the same. Okay, but for me, according to our syllabus, the test charge always in positive sign. So we just follow the syllabus lah. Okay, so I just put the test charge at A. Let's say this is the position. Okay, so now the force exerted on this is Q3, Q3. So the force exerted on Q3 now just by Q1 and Q2. Okay, now between 1 and 3, positive and positive, they will repel each other, isn't it? So the force exerted on Q3 just directed to the left. Or I think I need to sketch clearly now, sorry. So positive test charge. Okay, this is Q3. So between 3 and 1, positive and positive, they will repel each other. So the force now just directed to the left. That one is F on 3 by 1. At the same time, the force also exerted on Q3 by Q2. Again, positive and positive, they will repel each other. So the force exerted on Q3 still directed to the left. That one is F32. But now the condition is the resultant force equals to 0, isn't it? To the left, they are not cancelling each other. So the resultant force exerted on Q3 is not equals to 0. So it's not suitable to be here. Okay, now I just put the charge at C, which is at the right side of Q2. So this is our positive test charge. So the force exerted on Q3 now, again, just by Q1, also by Q2. So between 1 and 3, positive and positive, they will repel each other. So this is F on 3 by 1. At the same time, the force also exerted on Q3 by Q2. Again, positive and positive, they will repel each other. The second force is F on 3 by 2. See? F31 and F32 still directed to the right. Alright? They are not cancelling each other, isn't it? So the force cannot be here because the condition is the resultant force equals to 0. Okay? So I just put it here at B. And this is Q3. Okay? So again, the force exerted on Q3 by Q1 and Q2. So between 1 and 3, positive and positive repel each other. So the force exerted on Q3 just directed to the right. That one is F on 3 by 1. At the same time, the force also exerted on Q3 by Q2. Again, positive and positive, they will repel each other. So the force exerted on Q3 just directed to the left. That one is F32. So F31 just directed to the right. F32 just directed to the left. They may cancel each other, isn't it? So the best position just in between 1 and 2. So this is the way how do we select, okay, the best position for the third charge, where the resultant exerted on it just equals to 0. Okay, so remember, we need to understand this principle. Okay, because in exam normally they will ask you to find the separation or distance, but we need to know which position is the best for the particle to obey the condition given. Alright, so in this case, the resultant force exerted on 3 equals to 0. The resultant force exerted on 3 equals to 0, where the force exerted on 3 is F31 and F32. So F31 plus F32 equal to 0. So the vector, vector of F31 and vector of F32. So F31 is directed to the left. Wait, I need. Oh, sorry. I think we got something wrong here. The label is wrong. Okay, I suppose this is F32. Sorry. Okay, so this is F32, and this is F31. Okay, sorry. Because according to our assumption, the charge is positive lah. We just take a positive test charge. Okay, so F32 just directed to the left and F31 just directed to the right. So in this case, F31 just directed to the right, it must be positive lah. Okay, while F32 is directed to the left, it must be negative. Okay, sorry, my mistake. Okay, to like this. Okay, so again, F31 is directed to the right, so it must be positive. And then F32 just directed to the left, it must be negative. So F31 minus F32 giving you 0, because this is the condition given in that question. So based on this, by rearrange the equations, you will get F31 equals to F32. And then we just expand the equation. F31 equals to Q3 Q1 over R31 squared. F32 equals to Q3 Q2 over R32 squared. So K and K cancelling each other, also Q3 and Q3 cancelling each other. So we just substitute Q1, also Q2, R31 and R32. Okay, in this case, R31 is the separation between Q1 and Q3, which is 45.8 centimeter. Don't forget to convert it to be in meter. Okay, and then the second separation is R32. R32 is not given here, so we just leave it to be in R32 symbol. Okay. Okay, so for this you will get R32. So R32 getting now is 0.542 meters. But again, based on the question, they ask you to find the position of the second charge, isn't it, which is X. So in this case, X equals to R13 or R31 plus R32. So we just calculate R32 here. So X equals to R31 plus R32. R31 given already. Given already here. And the R32 calculated just now. Okay, substitute here, and then you will get the separation of the second charge from the first charge. Okay, so this is the way how do we answer the question. Okay, now let's continue by the next question, which is question number 2. Alright, so what do we have now? 3 charges are located as shown in the diagram below. So what do we have? Q1, Q2 and Q3. Okay, for this question, okay, the charge given just randomly here, so I think we need to numbering each charges and easy for us to calculate later. Okay, so I just label it by 1 representing Q1, and this is Q2 and this is Q3. Okay, so Q1 is a positive charge while Q2 is negative charge, and Q3 also a negative charge, where the separation between 1 and 2 given as 20 centimeter and separation between 2 and 3 given as 35 centimeter. Okay, so the question asks you to determine the magnitude and direction of the resultant force exerted on the negative 3 microcoulomb charge. Negative 3 microcoulomb charge is the second charge, isn't it, which is Q2. Okay, so basically we need to know, okay, the direction of all the forces exerted on Q2. Okay, now the force exerted on Q2 just by Q1 and Q3, isn't it? Okay, we just do it one by one. First, Q1 is a positive charge, Q2 is a negative charge. So according to Mr. Coulomb before, different charges attract each other. So the force exerted on Q2 must be towards Q1. They will attract each other. So this is F on 2 by 1, which is directed to the left. At the same time, 2 and 3 also react each other, okay, to each other. So Q2 is a negative charge, Q3 also a negative charge. So negative and negative repel each other, according to Mr. Coulomb ideas before. So negative and negative repel each other. So the force exerted on Q2 just directed upwards, okay, away of Q3. So seems like This is F23 lah. The force exerted on 2 by 3. Repel each other should be away, also upwards, directed upwards. So seems like F21 is really on the X component, while F23 is really on the Y component, isn't it? So by talking about two different axes or direction, which is X and Y, remember, in calculating the resultant, we need to use the square root equation before. Square root. Okay, before that, we just calculate F21 and F23. Okay, separately. So F21 equals to KQ1 Q2 Q1 over R21 squared. So K just a constant. Q2 and Q1 given already. Q2 is 3 microcoulomb. Q1 also 3 microcoulomb. And R31 is the separation between them, between 2 and 1, which is 20 centimeter. Convert it to be in meter, equal to 0.2. Okay, make it squared. Again, force is under vector. So in substitution, okay, for the value of Q2 and Q1, we just take the magnitude only and ignore the negative sign here, because positive and negative representing direction. Okay, so we just calculate the values here now. F21 getting now equals to 2.025 Newton, which is directed to the left. See, we just take the direction, easy for us later. Because normally for any vector which is directed to the left, it must be negative in our calculation for the resultant. Alright, and then we just calculate F23 again. F23 is the force exerted on 2 by 3. Okay, so F23 equals to K Q2 Q3 over R23 squared. K just a constant again. Q2 and Q3 given already. So this is Q2 and this is Q3. And remember, in substitution, we just ignore the negative sign here. And we just take the magnitudes. And then the separation between 2, 3. The separation between them is 35 centimeter. Convert it to be in meter, equals to 0.35. Make it square. So we just calculate the value of F23. And then you will get F23 equals to 0.992. Oh, what is the unit? Something is missing here. The unit is Newton. See, be careful. One mark lost already. Newton. And then it just directed upwards. Okay. So basically, F21 just directed to the left. It just lay on the X component. That one we take it as F2X lah. While F23 now is really on Y component, which is directed upward, we take it as F2Y. And resultant on X equals to F21. Resultant on Y equals to F23. So this is the resultant actually. Resultant on X component and the resultant on Y component. Why? Because in calculating F2, okay, the force exerted on Q2 equals to square root of resultant on X square plus resultant on Y square. Resultant of force lah, forces. Okay, so on X the resultant equals to F21. Substitute F21 calculated before, and the resultant on Y component equals to F23. So we just substitute the values calculated just now, which is F23 representing the resultant on Y component, and then you will get the resultant force exerted on on Q2 equals to 2.255 Newton. Alright, and remember, force is under vector. Don't forget to calculate its direction using the equation of tangent theta equals to resultant of force on Y over force on X. So by rearrange the equation, you will get theta equal to arctangent F2Y over F2X lah. And substitute the value of F2Y and F2X calculated before. Alright, remember we got modulus here, so that you will get theta equals to 26.1. So where is the position? So remember, we need to know. So take out the axis first. This is the axis. Okay, the value of Y is positive. Y is positive here. X is negative. X negative should be here. This is X negative. Remember, for the axis, positive X, negative X, positive Y, negative Y, isn't it? Okay, so the resultant on Y is positive. Resultant on X is negative. So the vector should be here. This is the vector, where the angle just be here. So now theta just located above the negative x-axis. So state the direction. Theta getting now is 26.1 degrees, which is above the negative x-axis. So this is the way how to identify the direction. Or maybe you don't have to write down the statement here to be like this, but we just sketch the diagram. It's okay, but you need to label lah. What is the force and what is the value of theta completely. And because 1 mark normally given for this. 1 mark given for the answer and unit, and 1 mark given for the statement. Okay, remember that. Okay, next. Let's continue by question number 3. What do we have now? Okay, number 3 is under electric field. So remember, question number 1 and 2, we are discussing about the electrostatic force. But now, for number 3, we are discussing about the electric field. Alright, so what is the question now? 3A. Determine the net electric field strength experienced at point P due to the two charges position as shown in the diagram below. Okay, now what do we have? Two different charges, which is Q1 and Q2. And there is a point given, which is point P. So remember, by giving you point, seems like there is nothing. What do we have? Just position only. There is no particle. The particles involved now just Q1 and Q2 only. So P just a position, just a point. Okay, there is no particle on that point. Alright, so now they ask you to find the resultant or the net electric field strength exerted on P, which is by Q1 and by Q2. Okay, so for this, first we need to identify the direction of E for both particle or charges, which is Q1 and Q2. Okay, Q1 given is a positive charge, so the direction of E should be outwards, to be like this lah, out, to be like this. And Q2 given is a negative charge, so for any negative charge, the direction of electric field should be directed inwards. Okay, so now this is point P. Point P located at the right side of Q1. At the same time, P just located at the left side of Q2. Okay, so we need to find the direction of electric field exerted by Q1 and Q2 lah separately. Okay, so this is point P and this is Q1. So E exerted on P by Q1, just okay, we just elongate E here. So this is E, elongate E. So E exerted on P by 1 just directed to the right. That one is EP1. We just take this E only, ignore others. Why? Because P located at the right side of Q1. Elongate the line. So this is E on P by 1. Okay, at the same time, P just located at the left side of Q2. So this is Q2 and the electric field just directed inwards. Okay, so elongate the line. Okay, we just take this line only. Why? Because P just located at this side, isn't it? Okay, elongate the line. Elongate the line. So E on P by 2 also directed to the right. Okay, alright, so basically E exerted on P equals to E on P by 1 plus E on P by 2 in vector. So EP1 directed to the right should be positive. E on P by 2 also directed to the right, also positive. So still the same lah, EP1 plus EP2. And then we just calculate EP1 and EP2. EP1 equals to KQ1 over RP1 squared. So again, K just a constant. Q1 given already, this is Q1. Alright, RP1 is the separation between point P and Q1. So the separation given is 0.4. Substitute all the values and then you will get the answers, which is 3.7 x 1.5 okay, Newton per Coulomb, directed to the right. And then we just calculate EP2. EP2 equals to KQ2 over RP2 squared. So again, K just a constant, Q2 given already. Remember, electric field strength is under vector. So in substitution, we need to ignore the negative sign here. We just take the magnitude only. Why? Again, because positive and negative just representing direction only. Okay. Alright, RP2 given is the separation between P and Q2 is 0.2. Substitute into the equation and then we just calculate the values. You will get EP2 equals to 4.5 exponent 5 Newton per Coulomb. Still the same, directed to the right. So EP1 should be positive, also EP2. And substitute into this equation and then you will get the answer where the resultant now just directed to the right. Okay, so means that resultant of electric field strength exerted on P still directed to the right. Okay, next question number 3B1. It's quite easy lah. And the diagram below shows the electric field lines near 2 point charges L and R. Identify the polarity of these point charges. Okay, so now according to this diagram, we have two different charges, which is L and R. So they ask you to identify the polarity of these two charges. It's quite simple. According to L, the direction of electric field lines not just directed inwards. So inwards, we know that the charge should be negative, isn't it? While for R, okay, the direction of electric field lines here still directed inwards. So inwards means that the charge also negative. Negative and negative, they will repel each other, isn't it? So the answer should be negative and negative. Something is wrong here. Okay, the answer of this should be negative. Okay, it's quite simple. Simple, eh? Directed inward should be negative. Still directed inward, also negative. Negative and negative repel each other. See, they are repelling each other. So correct lah. So this is the way how to identify the answer. Okay, next question number 3B2. Okay, a charge of positive Q is located 1.5 meters to the right of a point P. Where would you have to place a charge of positive 2Q so that the net electric field strength at point P will be 0? Okay, simple. So this is the situation. There is a point, which is point P, and then the first charge now just located at 1.5 meters to the right of point P. So this is point P, and at 1.5 meters there is a particle which is positive Q charge. Okay, so now they ask you to find a position where by locating a positive 2Q charge, then the net electric field strength at point P just equals to 0. Okay, again, now there are three different positions, which is position A at the left side of point P, position B in between point P and Q1 here, and position C, which is at the right side of Q1. So which position is the best to locate this particle so that the net electric field exerted on P just equals to 0? Okay, it's quite simple. We need to do it one by one. Let me show you. Okay, by locating 2Q charge at A. Okay, simple. This is Q2 and this is Q1 lah. Okay, Q2 equals to positive 2Q and the magnitude is 2Q. Okay, so now based on this, Q1 is a positive charge, so direction of E1 just like this. This is E1. Okay, so by elongate the line, E1 just directed to the left. That one is E on P by 1. So by locating Q2 at A, Okay, so this is E produced by Q2. That one is E2. Okay, I think we need to use different color lah, so that we can see it clearly better. And let me change the color first using green. Okay, by locating the charge to be here, so this is E2, where this is Q2 lah. So elongate the line. This is E2. E on P by 2, sorry, E on P by 2. Okay, so E on P by 1 just directed to the left, E on P by 2 just directed to the right. So two different direction, negative and positive, so that they may cancelling each other. By locating Q2 at A. Okay, by locating Q2 at B, can we have that situation? Okay, let's do it again. Okay, E on P by 1 still same, and maintain because Q1 fixed over there, so we don't have to change the situation. This is this is E on P by 1. Okay, by locating the second charge of Q2 at B, okay, so direction of E2 just be like this. This is E2, and which is by Q2. Alright, so in this case, we just elongate the line. So E2 still directed to the left, E on P by Q2. Okay, so in this case, EP1 just directed to the left, EP2 also directed to the left, though, so they are not cancelling each other, isn't it? So that the net electric field here cannot be 0, so it's not suitable to be here. Or by locating the second charge at C, still same, this is E2, which is by Q2 lah. So we just elongate the line, still the same, E on P by 2 still directed to the left, same direction with EP1, isn't it? So they are not cancelling each other. Again, it doesn't obey the principle, because EP1 just in negative magnitude, EP2 also just in negative magnitude, they are not cancelling each other. So the total or net electric field strength at point P cannot be 0 lah. So it's not suitable to be here. So the best position just at A, because we are talking about two different direction. Okay, alright, so this is the diagram lah. Okay, by giving you point P, Q1 located at the right side of P, so that Q2 must be located at the left side of QP, on point P, at the left side of point P, so that they may cancelling each other based on our discussion before. Alright, okay, so in this case, point P, and this is EP1, elongate the line, the electric field line by Q1, so that you will get EP1, which is directed to the left. At the same time, this is E2, so elongate the line, so E on P by 2 just directed to the right. Okay, so the separation between P and 1 given already, which is 1.5 meters. So separation between P and 2, we just take it as X, because they ask you to find the position, where will you have to place. So they ask you to find X here. Okay, so E on P now, resultant on P equals to 0, the resultant of electric field, E on P equal to 0. So what do we have? EP1 plus EP2 in vector. So EP1 just directed to the left should be negative, EP2 just directed to the right should be positive. So by rearrange the equation, you will get EP1 equals to EP2. Transfer EP1 to the other side, you will get this. So that EP1 equals to KQ1 over RP1 squared, and EP2 equals to KQ2 over RP2 squared. Again, K and K cancelling each other. Q1 given already, positive Q. Q2 given also, which is positive 2Q. RP1 given is 1.5. RP2 is X, substitute into this equation. Okay, Q and Q cancelling each other again. Alright, so giving you X. So X getting now is 2.12 meters, which is to the left of point P. Or at the left side of point P, which is at distance of 2.12 meters. So that the resultant just be 0. Okay, based on this. Okay, and then question number 4. What do we have? Okay, still under electric field strength subtopic. Okay. Alright, so what do we have in question number 4? Two charges are positioned as shown in the diagram below. What do we have? Q1 and Q2, separated by 4 meters. And then there is a point given, which is point A. So remember again, point just a position. There is no particle or charges on it. Okay, what do you have? Just position A only. Alright, so position A now just located at 2 meters from Q2 or 6 meters from Q1. Okay, so they ask you to find the magnitude and direction of the net electric field strength at point A. So they ask you to find the net electric field strength exerted on A, which is by Q1 and Q2. And then a charge placed at A experiences a force of 4 exponent negative 3 newtons towards the right. Determine the magnitude and the polarity of this charge. So by locating another charge on point A, the force exerted on it given already and directed to the right. So they ask you to determine the magnitude of the charge located on A here and the polarity. What is the magnitude of the charge and the polarity of the charge? Where the force exerted on it equals to these values and just directed to the right. Okay, so in this case again, Q1 is a positive charge, so E1 just directed outwards. Q2 is a negative charge, so E2 just directed inward. So we need to find the direction of E1 and E2 exerted on A. Okay, A located at the right side of Q1, A also located at the right side of Q2. So we just refer to the electric field strength, which is at the right side of each particle. Okay, so this is E1. Elongate the line. We just elongate the line. So this is E exerted on A by 1. Okay, while this is E2, which is directed inward. Okay, elongate the line again. Elongate the line. So this is E exerted on A by 2, which is directed to the left. So remember, electric field or E now just under vector. So to the right should be positive, to the left should be negative. Okay, so we just calculate EA1 and EA2 separately. EA1 equals to KQ1 over RA1 squared against Q just a constant. Q1 given already, which is 8 exponent negative 6. And RA1 is the separation between Q1 and A, which is 4 plus 2 lah, which is 6. So that you will get 2 exponent 3 Newton per Coulomb, which is directed to the right. Okay, and then we just calculate EA2, which is KQ2 over RA2 squared. K just a constant. Q2 given already, which is 2 exponent negative 6. Remember, for any vector calculation, we just ignore the negative sign. Okay, again, positive and negative representing direction only. So we just take the magnitude of Q2, and the RA2 is 2 meters, substitute, and then you will get EA2, which is 4.5 exponent 3 Newton per Coulomb, again directed to the left. See, that's why we just ignore the negative sign here, because positive and negative now representing direction actually. Okay, so now by getting EA1 and EA2, so that E on A here equals to EA1 plus EA2 in vector. So EA1 is just directed to the right, so it should be positive. EA2 just directed to the left, so it must be negative. Then substitute the values of EA1 and EA2 calculated before, and then you will get the answers. where the answer is getting now is negative. And the answer getting now is negative. What does it mean? Make it positive first. Negative representing direction which is to the left. So this is the way how do we write the answer. Okay, don't leave the answer to be in negative. Don't leave the answer to be negative. We just make it positive first, and then we just explain what does it mean by negative sign here. It just directed to the left. And then by locating another charge on A, the force exerted is 4 exponent negative 3 Newton. Okay, determine the magnitude and polarity of this charge. Okay, it's quite simple. Alright, so by knowing the electric field strength at A, we may calculate the magnitude of the charge using F equals to QE. So this E on A calculated before, substitute into this equation. The force given already, 4 exponent negative 3, substitute into this equation so that you will get Q. So this is the magnitude of the charge. And then how about the polarity of the charge? Is it positive or negative? Okay, now according to the statement, it just towards right. And towards right. Okay, what does it mean? Alright, so according to the electric field and calculated before, the value is just negative, isn't it? Which is directed to the left. So this is our E. E just directed to the left. So based on that, we know that the right side is a positive pole and the left side now is a negative pole or area lah. Why? Because E always start from positive area towards the negative area. So according to E calculated just now, it just directed to the left, isn't it? So this is E, which is directed to the left. And then by locating the particle, what happened? The force now just exerted on it just directed to the right. So the force now just directed to the right. So remember, seems like the particle now attracted towards the positive area. So what particle attracted by the positive area? It must be negative particles, isn't it? Because negative and positive, they will attract each other. So the particle here should be negative. Okay. So if direction of E and F just in opposite direction, E and F just in opposite direction, polarity of the charge is negative. How do we know? Again, because the particle just attracted towards the positive area. So the best particle attracted by positive area is a negative charge lah. So this is the answer. Okay. So Q getting out is 1.6 exponent negative 6 coulomb, where the charge is negative. Alright. So the best answer, we just write down the answer lah. So that Q equals to negative 1.6 times 10 to the power of negative 6 coulomb. So this is the answer. Okay. I think enough for today. Next, we just continue by question number 5 for the second session of our tutorial class. Okay, so try to understand the concept, how to answer the question, and how to find the hidden info given in that question. Okay, I think that's all for today. Thank you guys. See you again. Assalamualaikum.